So we have learned about what the probability is. Today we will learn about the finding probability when we have two-step experiment. Two-step experiment. What does it mean, two-step experiments? For example, you roll die not once, but twice. Or you roll two dice, it's the same as roll it twice. Or you toss coin twice. Or you roll a die and toss a coin. So you do two experiments, and how we can find probabilities when we have two-step experiments. Let's consider it on the example if we rolling two dice. So what result we can get on the first die? Not normal, I'm talking about normal six-sided die. So what we can get on the uppermost face when we roll the die? Yes? Yeah, we can get 1, 2, 3, 4, 5, 6. What we can get, what results we can get on the second die?
Same.
Exactly the same die, same results. We write them here. 1, 2, 3, 4, 5, 6. So we make a table like this. And for example, if you look in on the total, when you roll two dice, and you look what will be the total when you add the results at the most uppermost face. So what we will get here when we get roll one on one die, one on another? What the total?
2.
2. Total here?
3.
3. So we can fill this table. And it will help us to calculate probabilities associated with this. 5, 6, 7, 8, 10, 6, 7, 8, 9, 10, 11, 8, 9, 10, 11, 12.
7.
When you roll two die and you add numbers that are on the top. When you roll 1 on one and one on another, total is 2. When you roll 6 on one and 6 on another, total is 12. How many total outcomes we have? How many?
36.
36. We have 36 possible outcomes. We have 36 possible outcomes. So to find, for example, probability of rolling 5, we need to count how many 5s we have here. We have 4 5s.
4.
So we have number of favorable outcomes, 4 divided by total number of outcomes, which is 36. Can you leave answer in this form?
1 over 9.
2 over.
You need to simplify it, it will be 1 over 9.
1.
What will be probability of get? Which number is most likely to get when you roll it? Which number will have highest probability?
7.
7.
7.
So what will be probability of get number
6.
greater or equal 10? Probability of get number greater or equal 10.
7 out of.
We count how many we
6.
have 10 or more. 6.
6.
1, 2, 3, 4, 5, 6. So it will be 6 over 36 equals 1, 6. So when we're doing two-step experiments, we can represent results in a table where we list here possible outcome on one step, here are the possible outcomes on another step. They don't have to be the same. You can roll die and toss a coin. So here we have, let's say, for die 6. What we'll have here if you roll and toss a coin? When we toss a coin, what result we can get?
Heads,
Head
tails.
or tail. So here will be head, tail. And we will have head 1, head 2, head 3 possible outcomes. So to find probabilities with a two-step experiment, we need to make a table. List possible outcomes of one step, possible of another, and then when we fill the table, we can calculate probabilities. Make sense? There is another way to deal with a multiple step experiment. And if this way works for two-step experiments, but if you have more steps, if you, let's say, toss coin 3 times, if you toss coin 2 times, we can make such table. It's not a very big deal. We can make, if you toss 2 coins, so we can have, on one coin we can get head, we can get tail. We can get on another head, tail, so total will be head, 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 tail, tail, head, tail, tail. So we can do that. But what if you toss coin 3 times? Can you represent it in such table? You will have to make it 3-dimensional, which will be quite difficult. So there is another way, and this way called tree diagram, which is very powerful way of finding probabilities. Tree diagram, which we will be using up to and including year 12. The tree diagram will be helpful in year 12 to solve problems as well as in year 8. Tree diagram. So let's consider if we toss 3 coins. What we can get when we toss first coin? Head or tail? Head, tail. This is the first step. Second step, we toss another coin. We again can get head or tail. We have head, tail, head, tail. And then we toss it 3rd time. We again can get head, tail, head, tail, head, tail, head, tail. So what will be the total outcome here? If you go along this branch, what is the outcome here? What we get here?
Head, head.
We get 3 heads. Head, head, head. If we go this way, head, head, and then tail, we get head, head, tail. Head, tail, head. So in this way, we can represent all possible outcomes. How many outcomes we have in total? 8. We have 8 outcomes. What will be the probability of get 2 heads? What will be the probability to get 2 heads when you toss coin 3 times? In how many outcomes we have 2?
3 over 8.
We have 1, 2, 3.
No, you missed one.
Where?
What?
2 heads? Is it 2 heads here? 3. 2 heads. We have 3 out of 8. If you want to find probability of get 3 tails,
1.
we have 1 out of 8. If we need to find probability at least 1 head, so more or equal 1 head. How many outcomes we have? 1 or more heads.
7 over 8.
7 out of 8. We have 7 outcomes has at least one head. At least means 1, 2, or 3. Make sense how it works in the tree diagram?
Yes.
Make sense or no?
Yes.
No, I can see that this side, yes, this side I cannot see any certainty. Does it make sense how you list possible outcomes?
That's how it goes.
But what we have when you toss coin, probability of get head or tail are equal. But that's not always the case. Let's consider the next situation. You have back with the marbles, and you have the in the back you have 5 white marbles and you have 3 black marbles. You take 1 marble without looking from the back. You notice what color it is, you put it back. And you take the second one. So we can get on the first, we can get either black or white. But what are the probability of get black?
3 of 8.
3 out of 8. And we need to write probability here. Because we have only, they're not equal chances. Because we have not equal amount of the black and white. We have 3 black out of, in total we have 8 marbles. So it's 3 8. So what the probability of get white? 5 8. So because we looked on it and we put it back, on the next step probabilities remain the same. We have again 3 8s, 5 8s, 3 8s, 5 8s. So what are the possible outcomes here? Black, 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 white, white, black, white, white. To find probability in this case, because they're not equal probabilities. Before, with the tossing coins, we have equal probabilities. Now they're not. We need to multiply probabilities all the way. 3 8s, we need multiplied by 3 8s. We multiply probabilities on the way, so it will be 9 over 64. What will be probability of get 1 black, 1 white here? 3 8s times 5 8s will be 15 over 64. Same here, 15 over 64. What will be the probability of get 2 white marbles? We multiply 5 8s, we multiply by 5 8s, 25 out of 64. So to find probability using tree diagram, you need multiply probabilities along the way. So what will be the probability of get 1 black, 1 white, doesn't matter in which order. Get white and black. How we can find from here probability of get 1 black, 1 white? We need to add these two together. Do we get here black and white? Yes. Do we get here white and black? Yes. So we need to add them together, will be equal 30 over 64 or 15 over 32. What will the probability of get marbles same color? Same color. Either both black or both white. How will we find it?
34.
We add this probability of get 2 black to probability of get 2 white. We'll get 34 out of 64, which will be 17 out of 32. Make sense how to use tree diagrams to calculate probabilities. Okay, that's all my explanations for today. Like, subscribe, and donate to help fight evil countries and organizations like Russia and Hamas support Ukraine and Israel.